Okay, in this, we will see how this tabular method or Quinn-McCloskey method or the other name for Quinn-McCloskey method is branching method. Okay, so how this branching method or tabular method or Quinn-McCloskey method that can be applied to minimize an expression which is in standard SOP, and we are also considering don't cares here. Okay, so the question is minimize F is equal to sigma M 6, 7, 8, 9 plus don't care 10, 11, 12, 13, 14 and 15. Okay, so what's the first step? You will be representing the binary equivalent of these min terms. Okay, so you will be representing the min terms of the sigma value, and also you will represent the binary equivalent of the don't care min terms also. So you wrote the min terms. This is for sigma m and this is for the don't care. And the process is repeated just as what you did for the previous SOP minimizations. Okay, you are finding out the group which has only zero ones, single ones, two ones, three ones, and four ones. And we found out that there is no group for zero here. So we are starting with the group with a single one. And you found out that the given min terms only 8 has that value. So you wrote the 8. It is just required to represent the min term value only. You don't need to specify m there. So it is okay to specify 8, just 8. And you wrote the binary representations. So you wrote the first group and second group having having two ones. So you found out that the minterm 6, 9, 10 and 12 have those are those minterms which gives you two ones in their binary representation. 6 and 9. 6 represents your sigma m, and 9 also represents your sigma m, but you can see 10 and 12 represents your don't care. Okay, so what I'm trying to say is that the process is repeated for all these terms 6, 7, 8 and 9, 10, 11, 12, 13, 14 and 15. The process repeats for all these terms, min terms as well as for the don't cares. And then from this group you will be comparing the first group with second group to make it a pair if there is any group which changes only by one bit change. Okay, and second and third group is compared. Similarly, third and fourth group is compared. And when you could compare, what you will do, you will put a tick mark here and then you make it as a group, make it as a pair group. Okay, in the next table. So next table is a group of pairs uh, by by combining or by comparing the previous table, you made these groups. So you got at pairs as the first group as 8 and 9, 8, 10, 8, 12. Similarly, second group as like this and third group like this. Okay, and from this pair group, you are just comparing one and two group to make it as a quad. Similarly, to second and third group to make it as a next quad. If you could compare and combine, then you will form the next table as quad. And we can see that you are able to make a quad from here also. So quads, the first, from by comparing the first and second, you could match these quads 8, 9, 10, 11, 8, 9, 12, 13, and 8, 10, 12, 14. Okay, similarly by comparing second and third group, you could make this second group in the quad table. And from the quad table you are going to form an octet table if you could compare the first group with the second group. Okay, so 8, 9, 10, 11 is compared with 6, 7, 14, 15, and those two quads will be combined to form an octet if they differ only in one bit change. Okay, so you just found out 8, 9, 10, 11, 6, 7, 14, 15 can be combined or not. So one changes to hyphen, one bit change, zero change to one, two bit change. So it cannot be combined. 8, so 8, 9, 10, 11 is compared with 10, 14, 11, 15. Okay, similarly 8, 9, 10, 11 is compared with 9, 11, 13, 15. 8, 9, 10, 11 compared with 12, 13, 14, 15. You will be combine it only when there is only one bit change. And you found out that 8, 9, 10, 11, 12, 13, 14, 15 can be combined. Okay, so 8, 9, 10, 11, 12, 13, 14, 15. See, it is a 1 remains as 1, 0 change to 1, 1 bit change, hyphen, 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 hyphen. So which means that those two can be combined. So all the combinations, you just write out. So all the combinations when compared, you are able to make it as a octet. 8, 9, 10, 11, 12, 13, 14, 15. So when you could combine, you will be providing a tick mark there. Okay, 8, 9, 10, 11 could be combined. Similarly, 12, 13, 14, 15 also could be combined. Similarly, 8, 9, 10, 11 other terms 8, 9, 12, 13. Similarly, 8, 9, 12, 13 and the other term can be combined. Okay, what about that? 8, 9, 12, 13. Similarly, 12, 13, 14, 15 can be combined. Similarly, so when you tried comparing with the other terms, you found out that only the 6, 7, 14, 15 remained unticked. All others you could compare. Okay, 6, 7, 14, 15 you couldn't match with any other groups here. So that is maintained as star. Okay, and you got the octet table, and the octet table also you cannot group with any other group, so that becomes the other unticked term. So this I name it as P as well as a Q. Okay, so the P and Q now becomes your prime implicant table entry, the entry in the prime implicant table entry. So what is the representation of this? It is actually BC, isn't it? If it was A B C D, it is BC. And what about this? It is A. Let's see. Yes, P is actually BC and Q is actually A. So I am representing P and Q, and from this is the only point where the change happens. Okay, so here in the column we will represent only the min terms. See, you know that in the question it was asked with min terms and don't cares. Don't cares will not be mentioned in the prime implicant table, but you will perform all the operations taking the don't case, but the last step when you write the prime implicant table you will mention only the min terms alone. You will not specify the max terms, sorry, not max terms, the don't cares. Okay, and for P you know that it covers only 6 and 7. How you understood that P covers only 6 and 7? Because in the P you found that it is a 6, 7, 14, 15. 6 and 7 are the min terms given. 14 and 15 are don't cares. So you don't need to specify that. 6 and 7 are put as tick there. Okay. Similarly, for the Q, you found out that 8, 9, 10, 11, 12, 13, 14, 15 other terms, and you found out that it is only the 8 and 9 are your min terms. The remaining terms are your don't case. Okay, these are don't case, so you don't need to specify that. So you put a tick mark under 8 and 9, which means that the P cannot cover Q. Similarly, Q cannot cover P, which means that P and Q becomes your essential prime implicants, isn't it? Every column contains only one tick. So these P and Q are essential prime implicants. So what is the answer? P represents your BC and Q represents your A. So it is A plus BC. A plus BC, your answer. You're just cross-checking it with your K map, and you found out that this is your octet and this is your BC term. Okay, here I made a mistake. This is 6, 7, 8 and 9 represents your 1 value. The remaining are don't cares. This is not 1, this is don't care. These are don't cares. Okay, 6, 6, 7, 8, 9. Okay, this is your don't care. 11 is your don't care. And this is also your don't care. Okay, so in order to group this two ones, instead of grouping as a pair, I can group with these don't cares and make it as an octet, and that is your A. And in order to group these two ones, instead of grouping as a 2, I am grouping it with this 2 don't cares and making it as a quad. That is how this is done. And what happens when the question was minimize instead of sigma m, if it was pi m, if it was pi m 6, 7, 8, 9 plus pi d 10, 11, instead of sigma d it was pi d 10, 11, 12, 13, 14 and 15. Okay, what is the change you require? All these steps maintains the same. There is no change at all. and the change happens at this place. Okay, this place, the prime implicant table remains the same. At this place, instead of representing B and C, you will be writing it as B bar, because when B is 1, it is B bar. B bar plus C bar, and this becomes your A bar. So what will be your answer? Your answer will be A bar dot, isn't it? The product terms within bracket. It is B bar plus C bar. That is the difference. That is the answer. Okay. So this is how you will perform or you will minimize the SOP as well as POS with don't cares. With don't cares, you just keep in mind that when the question is asked to perform with don't cares, you can make the tables considering the don't care, but at the last step, that is a prime implicant table, you will not represent the don't care. You will represent only the min terms or the max terms. Okay, suppose the question was like this. As I told you in the previous video, the question was like this. The question was given as sigma M 6, 7, 8, 9 plus sigma D 10, 11, 12, 13, 14, 15, and you are asked to find out the POS value. Okay, question is sigma, but you are asked to perform POS. Then what you have to do? You have to find out pi M, pi max term, by within brackets you just represent the max terms which are not in 6, 7, 8, 9 and 10, 11, 12, 13, 14, 15, because the don't case remains the same for pi also. For pi, the don't case remains the same. Okay, so you have to represent the terms which are not in this min term and don't care. That becomes your pi m value, and then you have to repeat this process. So that is how this is done. Okay, hope that is clear.